All right, good morning, everybody. So today we are going to start into something new, which is the prerequisite chapter. And then we're going to do a couple sections in there, actually, only one section in the prerequisite. And what the prerequisite is going to cover is it's covering some of the factoring that you hopefully had done last year and may or may not remember. So I don't want to assume that you remember much about factoring, which is why I'm going to start in the prerequisite chapter. And we're going to start from there and kind of give you a nice overview of factoring, starting basically with the beginning. So let's get started. So we're going to be removing common factors from polynomials as well as factoring special polynomial forms today. So it says the process of writing a polynomial as a product is called factoring. It is an important tool for solving equations for simplifying rational expressions. As a side note, we are going to be doing a lot of different types of problems that are going to require you to be proficient at factoring. So it is really important that you understand this and you work at this and make sure that you're proficient at factoring on your own, because much of what we do for the next couple of months is very dependent on you having some factoring skills. So let's talk about a couple of expressions here. So this is example one, and it says simply removing the common factors. And so what you need to do here is take out what I call and what most people call the GCF, the greatest common factor. So your first helpful hint here is that anytime you have a polynomial expression to solve, the very first thing that you should try to do is to pull out a GCF. And that's what we're going to do with all of these. So if you look in the first example, we have 6x cubed minus 4x. So 6 and 4 are both, 2 can be factored out of both 6 and 4. Now, out of x cubed and x, you can take an x to the first power out. So that's exactly what we're going to take out. So the GCF of this first expression would be 2 and then x. So we're going to take a 2x out of this, and we're going to take a 2x out of this. When you take a 2x out of a 6x cubed, you are left with 3x squared. And when you take 2x out of 4x, you are left with a 2. And so you can see that the common factor is 2x, as it lists right here, and that it took out the 2x out of both of the original 6x cubed minus 4x. Now, you can double check that you did this correctly by multiplying these two together. 2 times 3 is 6, x times x squared is x cubed, and then 2x times 2 is 4x. So indeed, we get the same thing. So that is factored. The last thing to do would be to take the 2x completely out of there and put it, what is left after you factor the 2x out in its own set of parentheses. And there you go. You can see it's 2x times the quantity 3x squared minus 2. The same as the last step. If you wanted to double check that you did this right, you can redistribute that 2x to both things inside the parenthesis. Now, looking at the next one, we have negative 4x squared plus 12x minus 16. Looking across at negative 4, 12, and 16, those are all divisible by 4. So we can take a 4 out of there. One thing to note, this is an x squared term, this is an x term, and this does not have an x. Therefore, there cannot be an x as part of the common factor because they all three don't have an x. So we're going to factor out a negative 4 out of each of these three terms. So you can see we did that right there. The last thing will be to write one negative 4 followed by what was left can all be written in one set of parentheses. And again, if you want to check that this was done correctly, you can simply take this negative 4 and redistribute it to all three things, and you will get negative 4x squared plus 12x minus 16. Part C, it is already partially factored for us in that you have x minus 2 times 2x, and then you have x minus 2 times 3. You actually don't want to distribute this out. You want to pull the x minus 2 away from what is left there. So we're going to write x minus 2 once, and then what is left gets rewritten in its own set of parentheses, just like we did in parts A and B. Now, these are the special forms of various polynomials, we'll call them. These are all going to mostly deal with quadratics and then cubic. But we have this difference of two squares right here, which is u squared minus v squared is equal to u plus v times u minus v. An example of that would be 9x squared minus 4. You can see that the 9 as well as the x have been squared. We do need to rewrite the 9 and the x as the quantity of 3x squared, and then the 4 gets rewritten as 2 squared as well. Once we rewrite it as the quantity 3x squared minus 2 squared, you can then fit this back into the formula you see right here, which is u squared minus v squared. U squared minus v squared, here's your u, that's the 3x, here's your v, that's the 2. So you simply put 3x in for u, 2 in for v, and you end up with 3x plus 2, 3x minus 2. And you can see it factored just like that. A similar formula, but probably a little bit more complex, is the one for sum or difference of two cubes. I'm not too worried about the perfect squared trinomials. We can skip over this for now. But this difference of two squares, which I just went over with you, and then this sum or difference of two cubes, this one's really important as well. And this one shows us how to factor if we have a sum of two cubes as well as a difference of two cubes. If you look up here, it's just difference of two squares, which are two things being squared. It has to be subtraction in order to factor this. For the cubes, for the third power, that is not the case. It can be addition or subtraction, and we are able to factor this. So as an example, if you look right here, we have x cubed plus 8. We do need to rewrite that, so it's something cubed plus something cubed. So the x cubed is already the something cubed, but the 8 needs to be rewritten as 2 to the third. Once we rewrite it as something cubed plus something cubed, you can see that it fits right into the formula right here. And so we can have x is the u and 2 is the v. And so we just go right through this formula and plug in x for u, x for u, x for u, 2 for v, 2 for v, 2 for v. And you end up with x plus 2 equals x squared minus 2x plus 4. Okay, so here's an example. This is a difference because it's subtraction of two perfect squares. So the x squared is obviously squared, but the 49 is also squared. So I am going to rewrite the 49. First, I should have rewritten it as x squared minus 7 squared. And once I have it rewritten as x squared minus 7 squared, it will fit right into this formula right here. X squared minus 7 squared. U is our x, v is 7. And so it would be x plus 7, x minus 7. And that's how that factors to that. Part B also follows right in for the formula. Not sure why my light keeps going off. I apologize. Okay, so part B also follows right into the formula. This would be my u, and this would be my v. This is a difference of two perfect squares. So this x plus 2 is the u, and then y is my v. So it would be x plus 2 plus y, and then x plus 2 minus y. Fits right into the formula. And this was just rewritten with dropping the parentheses. Okay, I think this is the last one we're going to do with this. Yep. So this one is, again, a difference of two perfect squares, but it's a little bit harder to see this because it actually doesn't even look like perfect squares. It's x to the 4th. So this all needs to be rewritten before we can fit it into the formula. Again, I'm going to go back to the formula. You have to have u something, one thing squared, minus one thing squared. As it stands right now, we don't have one single thing squared. There's, in fact, nothing being squared right there. So we need to rewrite this. And what you need to realize is that 16x to the fourth is the exact same as 4x squared squared. So if this square, 4 would make it 16, and if you squared x squared, you get x to the fourth. So now I have it rewritten as one thing being squared. The 81 can be rewritten as 9 squared. So what we end up with is 4x squared for my u, and then 9 is going to be my v. So what we can now do is fit it into the formula. U squared minus v squared is equal to u plus v, u minus v. And so 4x squared is my u, and then 9 is my v. So as you can see, it fits right into the formula, 4x squared plus 9, 4x squared minus 9. Now, you have to be careful, because when we split up an x to the fourth, what we end up right here is another difference of two perfect squares. 4 is a squared, x squared is squared, and 9 is squared. So this can still be split up farther into this. You can see we squared the 2x and then we squared the 3. It fits into the formula again. This becomes your u, this becomes your v, and then this part splits further into 2x plus 3, 2x minus 3. So this would be the complete factorization of the original problem, 16x to the fourth minus 81. Now, the next one I'm going to show you is going to be the formulas for the sums and difference of cubes. So let's get started. These problems are done in a very similar fashion as the last problems. You need to rewrite the original expression as something cubed plus or minus something else cubed. So x cubed is clearly cubed, but 27 is not written as a cube. So we need to rewrite that as 3 cubed. So now we have something, one thing cubed minus another thing cubed. So we can fit this right into our formula. I'm going to go back to the formula for a second. This right here is the difference of two perfect cubes. You can see it's u cubed minus v cubed. So we have a u and a v, and it has to be whatever is being cubed. And that becomes u minus v times the quantity of u squared plus uv plus v squared. So this formula, we're going to follow this formula for our first problem here. And this is our u, x is our u, 3 is our v, and we're going to plug it right into the formula. So it's u minus v, and then it becomes u squared, which is x, plus u times v, so 3 times x, plus the v, which is 3, squared, which becomes 9. So that allows us to split this x cubed minus 3 cubed. Part B is similar. It's a little bit more complicated because in part B, 3 is not a perfect cube. So the first thing that you actually have to do is what I always stress whenever we're trying to factor anything, which is to take the GCF out. You need to take the 3 out of here as well as here. What you're left with is a sum of two perfect cubes. 64 is 4 to the third power. And now that you have it written as x cubed plus 4 cubed, the x and the 4 become my u and my v. And then go all the way back to this formula again. There's your u, there's your v. This is a sum. You're going to follow this formula right here. U plus v times u squared minus uv plus v squared. And so going back to that, that's my u, and that's my v right here, sorry, u and v. So u is x, v is 4. The 3 just hangs out there, and then you have the x plus 4 times the quantity x squared minus 4 times x plus 16. Again, this x gets put in for u in the formula. This 4 gets put in for v in the formula. That's how you get these two things in the parentheses. All right, that's what I got for you today. Hopefully that made sense. Remember, if you are having any issues, you can email me. This stuff isn't exactly easy. It might have been a while since you've done any of this. So if you are having questions, please feel free to email me. And I will go over this the following day in class. So you're welcome to ask questions then also. Have a great day.